There's more value in the connections outside of these talks than actually listening to the talks themselves. We've spoken to a lot of very experienced, very tenured people who have lots of, great stories and mistakes that we can learn from so that we don't have to make them as well.
Is there a timer somewhere? There it is, thank you. So my name is Tyler Drake, and this is my recent experience with modules. Some background, I have a small video game hobby project like everybody. It's got 14,000 lines, 61 files, 12 C++ modules. The game binary is built as a shared object with 3 functions on it. Forgive the C, it just made it a little bit easier. There's init, there's tick, and there's cleanup. There's a shim application that loads this shared object, and in between ticks, it checks to see if the file on disk has changed. It's UB, but I get away with it a lot. So in that init function, the newly loaded shared object gets an opportunity to cannibalize state from the previous one before it gets unloaded. And when this works, that means I get a visual feedback loop that doesn't include game relaunch or menuing back to the place I was looking at before. The only manual step is initiating a build, and the only delay is the incremental build time. Now, editing a certain 320-line CPP file took like 4 minutes on my Windows desktop with a 4.5 gigahertz processor. Good enough. I've got this laptop, though, which has a weaker processor. It takes like 12 seconds. That's kind of awful. And that was fine until I tore my Achilles and I had to sit down for like 2.5 months. So I was using this laptop. So I was thinking, okay, how can I get this iterative build time to go faster? Well, C++ modules, maybe? Now, I had already modularized the project, and I was already using import std even. But I had some third-party libraries that were not yet modularized. And I thought maybe I could modularize those. Maybe they're really expensive. If you weren't aware, Ninja produces a .ninja log file that has the start and end times of each build target. So you can scrape that with a command line program and create like cool percentile data about your builds. At the bottom here, you can see that the 10 longest build times where all of these files names are listed, and I happen to know those things include a bunch of very header-heavy libraries, the ones I listed on the previous slide. That gave me a hint that, well, maybe modularizing those would speed up my build, because the most expensive files are the ones that include those things. Also, there's some other stats up here. We don't need to read those. We'll see differences in like 2 slides. So here's a way to wrap dependencies that do not yet provide modules. I don't know if I can stand by this. I'm not exactly an expert in this area. However, it did work for me on a couple of different systems, MS-50 and Clang. Excuse me. So yeah, what you can do here is you can make a module C++ file, include the headers, export the symbols, and then replace your includes with imports later. So what do we get? A 41.5% reduction in full build time, so down 21 seconds from 51 to 30. Similarly, the incremental build time was cut just about in half. This laptop still really isn't good, but that's pretty great. Also, other little things, like just the amount of content that was created, the size of the PCM files shrunk by quite a lot. There's a couple of incidental notes here. On my desktop Windows machine with a more powerful CPU, the iterative build time is like almost instant. I can't explain it by just like the difference in processor speed. Maybe I messed up, I don't know. It's very quick, it's excellent. Incremental build time was consistently measured on that one kind of big-ish file. It's not big in like line count, but it did a lot of things that required things from other libraries. On smaller files, the incremental build time is like 1 second, which is fantastic. Even on this laptop, it's 1 second. I have no comparisons with precompiled headers. I've talked about this not in a lightning talk before, but that question has come up. And finally, the fill build times on the previous slides are, they add up to like 8 times the actual wall clock time because 8 cores, and that's how the time is being measured. All right, off topic 1. Have you seen P1681 or P1689? It's like something about these tooling files. At least CMake produces them with a .ddi extension. You can dig in that directory and then build cool build graphs in your modules. I've got 2 sets like this. This other variety shows more detail. It shows like the individual partitions in your module. And I learned a lot setting this up. It was pretty cool. So that's something you can probably do. Yay, that previous document. Oh yeah, off topic 2. I'm interested in constructive solid geometry stuff. If you've done that before, please talk to me. I've been looking around for people all week. And I'm done. Thank you very much.